Okay guys, today we are going to find integers x and y satisfying this equation. This equation is 71x minus 50y equal 1. So the greatest common divisor of 71 and minus 50 should be 1. Okay. And the first thing I'm going to do is to rewrite this equation so that 50 minus 50 become plus. So become a plus number like this. And then we try to use the Euclidean algorithm to find the greatest common divisor of 71 and 50. So the first thing I'm going to do is to divide 71 by 50. So the remainder is 21. Next, I divide 50 by 21. So the quotient should be 2. And 21 times 2 is 42. The remainder must be 8. And next thing I'm going to do is to divide 21 by 8. So we're going to have 8 times 2, which is 16. So we're going to have 21 minus 16, which is 5. And then we divide 8 by 5. So we're going to have 8 equal to 5 times 1 plus 3. Then we have 5 equal to 3 times 1 plus 2. And 5 divided by 2 times 1 plus 1. And then we have 2 equal to 2 times 1. Okay? Sorry, it should be 1 times 2. And the last remainder is 1. Because now the remainder is 0. That means that 1 divides 0. So by Euclidean algorithm, what do we have? By Euclidean algorithm, we gotta have the greatest common divisor of 71 and 50 equal 1. Now let's find integers x and y satisfying this equation. We will start with next to last equation, which is 3 equal to 2 times 1 plus 1. And I gotta write 1 in terms of 3 and 2. And the next equation has the remainder of 2. So we gotta have 5 minus 3. So it turns out to be 3 minus 5 minus 3. And it's 3 times 1. And then we distribute minus sign. So we gotta have 3 minus 5 plus 3. Okay, we gotta have 2 times 3 minus 5. And the remainder of the next equation is 3. And 3 is going to be 8 minus 5. So we're going to have 2 times 8 minus 5. Okay? And minus 5 right here. Then we have to distribute number 2. We got to have 8 times 2. And plus 5 minus 2 plus 5 times minus 1. And try to simplify this number so that we can distribute number 5. So we're going to have 8 times 2 plus 5 times minus 3. For this equation, we're going to have 5 equal to 21 minus 8 times 2. So it turns out to be 8 times 2 plus 21 minus 8 times 2 minus 3. Okay, minus 3, and we distribute 3 into each term. So we gotta have 8 times 2 plus 21 times minus 3, and minus become plus. So it turns out to be 8 times 6. Then we gotta have 8 times 8 plus 21 minus 3. Okay, next one, we take a look at number 8. So number 8 becomes 50 minus 21 times 2. So we gotta have 50 minus 21 times 2 and 8 plus 21 times minus 3. Distribute number 8. This should be 51, not 50, right? Oh, 50. Okay, sorry. 50. Okay. So we're gonna have 50 times 8 and 21 times minus 16 plus 21 times minus 3. Okay, let's go to this area right here. So now we're gonna have 1, and we will add these numbers. So we're gonna have 1 equal 50 times 8 plus 21 times minus 19. Okay, great. Then what next? The next thing I'm going to do is to rewrite 21 in terms of 71 minus 50. So we're gonna have 50 times 8. 21 is now 70 minus 50 times minus 19. And we distribute number 19. Then we're gonna have 50 times 8 plus 71 times minus 19 plus 50 times 19. And then we add 50, right? Okay. Oh, now we have 50 and 71. So we gotta have 71 times minus 19 plus 50 times 27. Okay, let's make sure that this number, the sum of these two numbers turns out to be 1. So let's calculate. So we have 71 times minus 19 plus 50 times 27. And it turns out to be, let me calculate 71 times 19. We gotta have 170, 639, and it's 9431. Okay, actually it's minus 1349 plus 50 times 27. I think it's 135. Okay, it's it's 1350, and it turns out to be 1. Okay, great. That means that we gotta have 71 times minus 19 minus 50 times minus 27 equal 1. Okay, so that means that x can be minus 19, y can be minus 27. Okay, so x becomes 19 and y is minus 17 for this equation. Okay, and you can find integers other than x and y for this equation. Okay, I think you can find it yourself. And that's it for this video.